Welcome to BeyondBIM. I have recently had the opportunity to learn from other sectors outside of the AEC world, which has led me to this mini-series of episodes where I hope to bring to you thought leaders, experts, and professionals from across sectors such as defense, aerospace, automotive, and aviation. The topics will cover all things digital and transformative. Today's episode, I had the pleasure of speaking to Dr. Don Kinard from Lockheed Martin. By now, you will have heard many episodes from BeyondBIM that talk about digital twins, but what about digital threads? In this episode, Don explains to us the digital thread and how it is used by Lockheed Martin. We also discuss what it means to smaller organizations that are wishing to embark upon the digital twin or digital thread journey. If you don't know who Don is, he's a senior fellow for Lockheed Martin Aeronautics production operations and has been with Lockheed Martin for 36 years. Don supports digital transformation as well as programs such as the F-35. Prior to his current assignment, he was the lead for the F-35 production rate transition program and earlier the director of the F-35 production engineering, responsible for joint strike fighter tooling, planning, manufacturing engineering, and aircraft systems testing. And if that wasn't enough to keep him busy, he is also the lead for the Lockheed Martin Corporate Fellows manufacturing team, whose objective is to develop and share engineering, manufacturing, and sustainment technologies throughout all of Lockheed Martin's business units. And now, let's hear more from Don directly on the topic of digital threads. So thank you, Don, for joining us on BeyondBIM. The intention today is to really find out a little bit more about the concept of the digital thread. And this is something quite new to a lot of stakeholders, maybe outside of advanced manufacturing, who are starting to think about the digital twin journey. So to begin with, Don, can you perhaps explain for the novice, what is a digital thread and how is the concept different from a digital twin?
It's great to be here. First of all, they are two different things, but people confuse them all the time. So I'm not surprised there's some confusion there. And I also like to bring in the issues of model-based engineering and model-based enterprise at the same time. So the digital thread itself, that term was coined about 20 years ago, kind of at the beginning of the F-35 program, and it's some combination of Lockheed Martin and the Air Force Research Laboratory at Wright-Patterson came up with the term digital thread, and it was about the creation of 3D solid models and then the consumption of those models downstream by manufacturing, suppliers, and eventually sustainment. So look at digital thread as the connection between those pieces of information and the different systems they support or the different users that consume that data. So that's the digital thread is the highway, I guess, for the digital information. The digital twin itself is, and a lot of definitions, but it's really the product. It's really the model itself. It's really for example, when I create a 3D model of a bulkhead, that 3D model of the bulkhead is a digital twin. I create 3D models of the airplanes. Those are digital twins. And you can also have digital twins of processes like manufacturing processes where you simulate the build of the airplane in the environment, or you even data processes like you simulate the sustainment of the aircraft in the field and the movement of material back and forth. So there's all kinds of ways. You could have a twin, a physics-based twin of a fuel system or a hydraulic system. So those are just examples. And there's some controversy about whether a digital twin begins when you have a physical asset or if you don't have a physical asset. The bottom line for me personally is that I believe you have a digital twin first, and then you start having the physical asset, which is based on the maturation of the digital twin. So that's me. Now, all of this together is part of model-based engineering or model-based enterprise, however you want to look at it. So again, those terms which seem fairly new. Model-based engineering and model-based enterprise are kind of new terms, but they refer to the way we use a digital twin and a digital thread. So those, in a nutshell, that's kind of where we are. Again, it's important to understand the terminology, but the bottom line is until there's standardized definition, it's really hard to say something and have everybody know what you mean, and that's probably not going to change.
Yes, and many industries have their kind of own interpretation as to what a digital thread will look like for their industries as well. So one of the things you just briefly touched upon there was the differentiation between having a physical asset associated with the digital twin. Now, why is there a difference in opinion here that some regard that you do not need a physical asset where some say you do?
Well, in fact, there's by the way, I should credit the digital twin to Dr. Michael Greaves, and he was, I think, the first one that used that terminology. And the controversy is really that some people in the community, and in fact, AIAA that I'm a member of just had a paper come out where it talked about that you needed a physical asset for a digital twin. And prior to that, it was a digital system model. So it's a kind of a semantic thing about where you call it, but that's really and I don't want to say it's controversy as much as semantics, but to me, a digital system model and a digital twin are the same thing. So I kind of don't. I guess at some point you stop caring about the semantics and just care about the reality. But some people want to use a digital twin to mimic the product in the operational environment, meaning the closer your twin gets to mimicking the environment. For example, mimicking the structural life of an airplane, following the flight path or the flight data and collecting data from the airplanes in the field, the way that, for example, Tesla collects data from its cars all the time. And that data it collects from its cars is used to continue to refine the autonomy of the vehicles, for example. And it's the same kind of thing with airplanes. We collect a lot of data on airplanes, and that data is used to better support the aircraft. So again, the physical asset thing is more of a semantic thing, but it can be emotional for some people. Myself, it's not really emotional. I understand what I mean by it, and and the way we use it internally at Lockheed, and that's really all that matters, that we were on the same page.
Now, can you give us a bit of a practical example of how the digital thread is actually applied? Let's take the defense sector.
Well, actually, and in fact, I'll give you several stages. So the first real, I would say, usage of it with the digital thread is to get all of your suppliers and partners all in a 3D compatible digital world so that you can exchange models between you and your suppliers. All the data goes into a common database, and everybody can access information they need on a common. Now, not everybody's on the same PLM system or CAD system, so typically that's with the standardized STEM step models that we transmit back and forth to one another. We created for our suppliers. Some of the PLM systems and CAD systems generate the step models automatically. So that's the way we communicate. But the bottom line is I got to get everybody in the same database and everybody, because I can't have a 3D model unless I have it all together, so to speak. So that's the first step. The second step is, how do I want to consume that model? So in manufacturing, we want to consume it to do automation. For example, I want to use a lot of automated drilling like we do on F-35. And so I want the whole vectors. I want the material stacks because I drill at different feeds and speeds depending on whether it's titanium or aluminum. I want to know the thickness of that. I want to know the size of the fastener. So we have to construct a digital twin or the digital thread through the digital thread to be able to do automation. The same thing for robotic spraying, for example, putting coatings on. So that's one part. It's just a physical automation. Secondly, or thirdly, we really want to get the 3D data in the hands of our mechanics. So we want to be able to publish graphics. We want to use augmented reality to give them a good vision of it. We want to be able to, display it on TVs perhaps around the factory. We want to use optical projection to project up onto the airplane surface the data that we want. So instead of looking at a drawing, a model, or even a tablet, I will, actually can look right at the airplane, and my work instructions are right there. So that's another way. And then I think the final way, at least that we've been doing for a while now, is I'm measuring the aircraft as I build it. I'm using the digital thread and digital twins because I want to compare the actual as-built configuration to the as-designed configuration, and I want to do that in real time. Now with laser scanning and structured light, I can, and that's just incredible technology to be able to, as you're building it, to be able to compare those two and know that you're right and find problems early if you have issues. That has been extremely powerful tool for us. And the final stage, at least so far, and maybe there's more, is really the way we connect the data from one system to the other. Systems grow up kind of in silos, and the digital twin needs to be able to flow freely. Now, not just the 3D models, but all the data that's attributed to it needs to be able to travel seamlessly from engineering to manufacturing to suppliers and to sustainment. And that data needs to be all connected. And that is probably the next phase of the digital thread is the fact that all the data is connected and it's not siloed in these big IT systems.
And I think obviously a lot of other sectors are looking towards the defense sector to learn and understand how to apply these technologies into their own industry. So what lessons could the civilian sectors learn from the defense sector when it comes to the digital thread?
Well, it's an interesting question because I would probably have judged that some of the civilian sectors are far ahead of the defense sectors in terms of the digital thread. Let me give you some examples. I've seen the automobile industry, especially the racing car industry, take a tremendous advantage of the digital twins, of the digital thread to do computational fluid dynamics on their car bodies and wind resistance around the cars. I've seen Toyota's models of the car manufacturing, the very sophisticated models of manufacturing and the engineering products to go through. So I think that they're really starting and probably ahead of us because, again, they turn around products much quicker than we do. We can take from 5 years to 20 years to get a product from development into IOC or initial operation capability. Mm-hmm. And, they'll turn that around every year. So they have a much more of a vested interest in it. So I think they're probably ahead of us. And in fact, even on the data side, I think they're ahead of us. There was an article in the New York Times called The Robots Are Coming for Fill-In Accounting, which is a fascinating read if you haven't already seen it. But it talks about the fact that, manufacturing people are kind of used to having a target on our backs for cost reduction. Everybody thinks, well, I got to reduce the cost of producing the product. When, a lot of the cost is above the shop floor and the management and accounting and finance and some of those departments. And frankly, they're not used to having the targets on their backs the way that we do in manufacturing. But the bottom line is this data revolution, really another stage of the digital thread, digital twin. The data revolution is starting to look at the way we manage data in organizations, starting to look at robotic process automation and things like that. They're going to connect the data that, the data will be available at our fingertips and potentially available on like an Alexa, and actually a cognitive assistant that, answers questions for you about things, and which I think is super cool. I don't know that I'll see it because the data is hard to organize, but even Wall Street, in fact, instead of having all these analysts that deal with people, everything is analytics and artificial intelligence, and automated. So it's I know exactly. It's getting all automated. So everything is turning to automation.
And as you mentioned, of course, you talk about data and also some of the associated challenges with that. So apart from the data challenge, what other common challenges from the digital thread exist? And also, how could enterprises be more prepared for creating that seamless digital twin?
Let's talk about the challenges first. And the challenges are really the fact that typically systems like CAD, PLM, manufacturing execution systems, ERP systems, and sustainment systems, they grow up under what's called Conway's Law, which is a law that says that the systems tend to mimic the bureaucracy and the organizational structure of the organization, and they tend to mimic the processes. So, you grow up under engineering, you have a certain set of processes, manufacturing, finance and supply chain, or sustainment. And so the systems are not inherently designed to communicate with one another very well. So first you have this problem of the transmission of the data, but probably a bigger problem is having the entire enterprise understand how the data is used inside each of these organizations. What do the suppliers really need? What does engineering need? What does sustainment need to do their business? What kind of models? What kind of data? What is their business process that they're going to operate under? And then you've got to get everything organized for that. And so I've suggested that you take a systems engineering approach to data management and model management so that you know how to operate as an enterprise. And that's a big challenge, in fact, to get people to stick their head out of their individual silos for a minute and look at the bigger enterprise picture. Am I doing something that's benefiting my silo, my engineering product, or my manufacturing product, but it's not benefiting the enterprise as a whole? And so I really need to spend more time looking at the consumption of the information by the enterprise and how the enterprise transmits the data and how the enterprise communicates with other enterprises and other suppliers and things like that. So those are some of the things. And the second part of the question was what again?
So it was mainly about how enterprises could be better prepared.
Okay,
Yeah.
Very good. Frankly, I think it's a matter of understanding how your business works. It's amazing because we live in silos in a lot of respects. We don't really see the bigger picture of how the enterprise works and don't always understand, what the drivers are behind cost and span in various pieces of the organization. So we really need to, first of all, look at what is really driving cost and span, and what do we need to be able to, how would I call it, impact or move the needle on those key processes? Because you can put tools in, you can do lots of things. You can crowdsource responses, which is pretty typical. People go, well, what do you want to do now? How do you want? And so a lot of little things come up, but you have to keep your eyes on the prize, so to speak. You have to look at what are the drivers in your organization. So I think businesses need to, one, look at how their systems are connected, or look at how they're going to be connected. When you put in a new system, how are you really connecting it with the other systems that you have? Are you really spending time on it? Most systems today, and this is true across the industry, not just in the defense sector, but most of them require lots of mandrolic or manual labor to take data from one system to the other to do reporting. I have to take data from this system, compare data from this system. And in fact, most of those systems are connected with what we call point-to-point connections. So instead of being integrated, they're point-to-point. And I know that we're trying to move to a more of a enterprise service bus or integrated operational framework where all the data goes to a data bus and then you access any data that you need from that common bus. Those are the kinds of things that'll make a difference where people can get access. And, our employees expect easy access to data. They come out of college thinking, well, and they'll go, why is it so hard to get this data? Well, it's hard for a reason. And by the way, some part of our business is we tend to compartmentalize things for security reasons.
Yes.
That's one of the drivers, and that's a problem. We have to, there is no data future without a cybersecurity future. So, Lockheed is one of obviously the most hacked companies in the world, and we're hacked by the best of the best from all of the countries, and so we have to be really good at that. And in order, and by the more we integrate our data, the more vulnerable you are unless you take extra precautions on that. So again, the cybersecurity aspect of it, I don't know that anybody will ever come up with the golden bullet to kill the cybersecurity. So we have to be better and better all the time.
Absolutely. Actually, that's really fascinating that you mentioned cybersecurity. That's obviously a big challenge for a lot of sectors, but especially the defense sector. So, for the smaller companies that may not be as well versed, what should they be aware of in terms of cybersecurity and deploying digital twins?
Well, I think that's one of the key things because, for example, a lot of companies like Lockheed are vulnerable through our supply chain. And the fact is, you're right, small companies can't really do what Lockheed Martin does necessarily. So I think small companies have a couple of choices. One is the way they partner with companies like Lockheed Martin to protect themselves and to protect us in the same way. And two, there really are a lot of, how would I call it, firms out there that are specializing in cybersecurity these days. So I think the bottom line is that cybersecurity is kind of fundamental to your business, and no matter whether you're a small or big business. And again, you can get help from your partners, like us, because we're very used to it, or from other consulting companies and or firms out there. Blockchain has become very relatively well known, and I'm sure there's other activities like that. So it's just a matter of connecting and becoming aware. But again, everybody will need to be protecting themselves. I mean, you've seen the way that things happen, and with the electronic grids and everything. There's a lot of concern out there. So it's a general problem, and I know the government as well as industries are spending an awful lot of time and money preparing themselves.
Yeah, certainly if we think about critical infrastructures that are out there, and there's a lot of push, at least in the UK now, to digitize or digitally twin the national critical infrastructure. And of course, this is just a treasure trove for malicious cyber actors.
Absolutely. And that won't change. The integration of the systems makes you more vulnerable, but it also facilitates the future. I mean, it's kind of do I want to make progress, or do I want to stay where I am? And technology is going to move on. I've always used the analogy that we can decide to continue what we're doing. We can either continue making film or we can go digital. Okay, that's my Kodak moment. But that's what I'm saying is that there's the technology is going to move. And we've got to be in front of it. We want to, either ride the technology wave or you get rolled up underneath it. So you have a choice.
So, Don, you have extensive experience on the topic of digital twins and digital threads. If you could summarize your experiences into just one golden piece of advice, what would that advice be to organizations before they embark on that journey to digital twins?
Oh, that's a great question, and I think the real key is understanding yourself. Know yourself, know thyself, because understanding how you work as a business, how your business processes work. Where's the real cost and where's the real span time it takes you to develop products, and understand where you want to go. Meaning, if you don't have a future vision of how you want to operate in the future, then how will you know how to get there? So we start out sometimes with a lot of little incremental things that aren't part of a big vision. So we need that vision. We need that. How do I want to operate? How am I going to be more efficient? How do I want to work? And then move incrementally towards that.
Thank you for tuning in to listen to BeyondBIM podcast. If you enjoyed this episode and want to hear more from our latest episodes, then you can visit BeyondBIM, which is available on SoundCloud and iTunes and all the other major podcast providers.